Next, we look at thermal power plant run by a gas turbine. So here the prime move will be a gas turbine. Just look at the layout. It is very you can easily relate it with the other thermal power plants. As usual, we'll start from the alternator. This is the main generator which is going to produce the electricity. So this generator is run by a turbine which is a gas turbine. That's why we are calling it as gas-based thermal power plant or gas turbine power plant. Okay, so here you're using a gas turbine. Okay, now how you are going to run this turbine? As the name tells you, this turbine is going to run with the help of a gas. So here there is a setup called a compressor which will be compressing the atmospheric air and it will be giving outside. Okay, so this compressor compresses the air so that when you compress the air, the pressure becomes intense. So that high pressure air is sent to the regenerator where the temperature will be increased here. So this temperature increased, pressure increased atmosphere will be entering into a combustion chamber where the heat energy will be produced. So that gas will be used to run this gas turbine. So this gas, once it enters here and it has to leave outside, no, so that once it enters the gas turbine and leaves outside, we'll call it as exhaust gas. So those exhaust gas also pass it back to regenerator, through which you are again getting it to the sending it to the combustion chamber. Okay, so this is the overall layout of your thermal power plant run by a gas turbine. But what is the problem you'll face here is you have a compressor here, no? This compressor has to be started. So we require a starting system. Okay, you can see a starting motor here. Okay, so you require a starting motor for this power plant to run this compressor. So if you are using the output of the alternator, or if you are using the alternator input power itself as the input as the support for a compressor, obviously output will be low. Okay, so this is one disadvantage. So here it is not much used in all the applications, rather it will be used as a standby for your hydroelectric generating hydropower stations. Okay, so when you compare diesel power plant and your gas thermal power plant, you can see that diesel power plant will be more suitable for temporary standby applications. Though this gas power plant is also suitable for standby applications, the components which we use here require some external source of external help in the form of an external source. So obviously the efficiency will be low. So when you compare all the power plants so far we have discussed now, this thermal power plant run with the help of a gas turbine has the lowest efficiency or the least efficiency. Okay, other than that it's they have their own advantages. So that's why they are still in practice, but they don't find a very wide range of applications. That's it. Thank you.